Hello everyone, I'm Yufu from University of North Texas. My presentation is about accelerated biodegradation of Kenaf fiber and cell protein composite using Pectinase under soil burial condition. The most common plant pot in the market is made from plastic. Recently, the biodegradable pot were designed to provide same functions as the plastic ones. In addition, the biodegradation process of the pot could provide plants with nutrition through proper formulation. Kenaf bast is one of the popular nature fiber used as a reinforcement of composites. It can be used to design biodegradable pot. However, the degradation time of Kenaf fiber could be long according to the environmental condition. Adding extra enzyme could be one of the solutions to control and accelerate its biodegradation. Generally, the biodegradation of biomass-based composite in soil could be affected by characteristics of material itself and exposure conditions. Of course, we need to design the material in order to get better controllable degradation. At the same time, we need to consider the exposure conditions as well. In this study, we investigated the biodegradation behavior using one kind of enzyme, which is pectinase. Pectinases are used to hydrolyze pectin, resulting in a separation of fibers and non-fiber components. In order to compare the degradation of Kenaf fiber cell protein composites under soil burial condition with and without pectinase, first we prepare samples. 1 inch by 1 inch specimens were cut after well and buried them in soil with 50% of moisture content for 45 days. Enzyme was added with water into soil. During the test, control the temperature of the soil at 38 degrees Celsius. The reason that we choose lower temperature is high temperature accelerating the degradation process according to the research, and we want to simulate the real condition of degradation outdoor. As you can see, after 45 days, the fragmentation appeared and the specimens lost their structure. In order to evaluate the biodegradation rate, we plot the data calculated by the equation. In the first few days, the plot was going down since the water absorption happened. After about 10 to 15 days, a small amount of pectinase accelerated the degradation of specimens significantly. As we said before, pectinase hydrolyzes the pectin, resulting in separation of fibers and non-fiber components. The loose structure of materials in the soil increased the exposure area and accelerated the mold growing. When we see the degradation without pectinase, after 45 days, the degradation was almost zero, which means without enzyme, the specimens did not degrade. It is degradable, but the time could be very long. Except the degradation test, we also compare the surface temperature variation of Kenaf fiber cell protein composites versus black polypropylene material using thermocouple. The black polypropylene is one of the major nursery pot materials that are used today. The temperature and time curve clearly indicated that the Kenaf fiber and cell protein composites observe heat slower than the polypropylene. The direct impact is on soil temperature inside the plant pot. In return, impact how the plant grows. Many research indicated that the black polypropylene lowered the root mass, especially for heat-sensitive plants. Comes to the conclusion, degradation of Kenaf fiber cell protein composites is not obvious at the temperature of 38 degrees Celsius under soil burial condition without pectinase. 4% of pectinase can accelerate the degradation process of Kenaf fiber cell protein composites significantly up to 50%. The degradation differences between adding 4% and 0.4% of pectinase is less than 10%. Heat absorption of Kenaf fiber cell protein composites materials is slower than that of polypropylene.